linear regression. Okay. I'll collect during the break. Okay. So linear regression is all about coming up with an equation to illustrate the relationship between two numeric variables. So we talked about correlation, okay? So we had correlation. In correlation, we got a value r, right? To describe a relationship between two numeric variables. And do you guys remember the rules about r? Okay, you need to know. Okay, if r is close to 1, it's strong. Or if r is close to -1, it's also strong. If r is positive, there's a positive relationship. If r is negative, it's a negative relationship. If r is close to 0, it's a weak relationship. Okay? Two numeric variables. Okay. So do you guys remember in algebra the equation of a line? How do we write the equation of a line? No. Okay. All right. So you have y equal to, I'm going to call it slope times the intercept. I'm sorry, not slope times the intercept. Slope times x plus the intercept. Okay? So sometimes it might have been written y equals mx plus b. Okay, this might be familiar. You have a slope times the x plus an intercept. Okay? And this is a line. This is called our linear regression line. And it is the line we use to make predictions for linear relationships. Okay, so let's try out an example and just make sure we can do this. Okay. So you might have. You need me to go back?
You will post the notes in the website.
Yeah. Okay. So for linear regression, we often put a small. I'll illustrate this. We often put a small hat over our y to indicate that this is a prediction. Okay. The blank over the y indicates that it is a prediction. So we might say something like, so let me illustrate how we might come to a linear regression line with something like Excel. Okay, so let's say we want to know, is there a relationship between your height and your mother's height? Okay? So we ask, what is your height and mother's height? So I'm just going to, I'll just write you and mother, okay? And so I'm going to just make up some numbers here, okay? But, let's say you are 64 inches tall and your mother was 66 inches tall, okay? And then we ask someone else, how tall are you? And they say, I'm 60 inches tall and my mom was 59 inches tall, okay? Does this make sense what we're doing? And we're just going around and we're asking people, how tall are you? And we ask, how tall is your mom? So somebody says, I'm 62 and my mom was 63. So maybe we'll just ask different women. And somebody says, I'm 67 inches tall and my mom was 66. And someone says, I'm 63 inches tall and my mom was 63 inches tall. Okay. So I'm going to use this. So let's say these are our 5 data points. I'm going to insert a scatter plot, and it looks something like this. Okay, can we see this? Okay, so these are just the different people along with their heights. Okay, and let's get the equation. Okay, so I don't know if you guys can see this. Let me just make this. So in Excel, you can ask it to, oops, I don't know how to make this bigger. Okay, well, it's tiny here, okay? But Excel produces a trend line for us, okay? So we just ask, how tall are you? How tall is your mother, okay? And it says y is equal to 0.9925 plus 6716, okay? And so we can actually, and I can add more data points, and I could say, okay, let's say, I don't know if anybody's willing to volunteer some information, but let's just say, somebody else was, 5 feet tall, so, or 5'1", so they are 61 inches tall, and let's say their mom was 63 inches tall, okay? And then maybe someone else was 61 inches tall, but their mom was short, 58 inches tall, or something like that, okay? And so we can see, adding these data points affects the trend line in our equation a little bit, okay? All right, so here I've just made up some data based on you and your mother's height, imaginary, okay? So just some imaginary data. And so this line represents a trend line or a prediction line, okay? And so what it says is that if somebody is 61 inches tall, how much do we predict their mother to be? We expect the mother's height to be right here, which is just around 61 inches tall, okay? Now, when we look at the data points, we don't actually see that. We see one person who's 61 inches tall whose mother was 58 inches tall, okay? And we see someone else who's 61 inches tall and whose mother was 63. But if we didn't have a data point and somebody else came along and said, I'm 61 inches tall, and we had to predict how tall their mother was, what would we predict? We would predict the mother's height to be right here where this line is located. Does that make sense? Okay, and so we can also make predictions. If somebody says, I'm 66 inches tall, how tall do you predict the mother to be? We would predict right here, okay? I used Excel, and so I'm not going to there is a process. We're not going to go over, okay? There is a process to get this equation by hand, okay? But it's tedious and probably much more involved than any of us want to care about. And if I taught you that, I feel like all of your mental energy would be spent, or just, I mean, right, we have 3 hours, right? And I would feel like our entire class time would be spent on the mechanical process of getting this number here, okay? And the truth is nobody, even modern day statisticians, nobody gets this equation by hand anymore, okay? We all just plug it into a computer and we say, computer, give me this thing, okay?
Even though we need to know if we don't have Excel, how can I get the number?
If you don't have Excel, there's no, okay, if you don't have a statistical software program, there's no way to get this number, okay? I mean, you can do it by hand, but I don't want to teach it to you by hand because it's a waste of time.
Yeah, I know.
Huh?
I understand what you mean. I understand what you mean.
I probably, okay, in the homework, I probably will not ask you to do this. What I might give you is I might give you the graph with the results, okay? Now, I could record a video that will show you how to get this in Excel, just in case in the future you come across some data and you want to create a linear correlation line yourself, okay? Don't say you'll never use it, okay? Okay, but the truth is it's you know, we don't need to worry about how to calculate this by hand, right? I mean, in elementary school you learn how to add numbers, but if somebody says, here's 300 numbers, I want you to add them up, you're not going to do it by hand, okay? You might not even do it with a calculator, okay? You're probably going to throw it into a computer and say, add these up for me, okay? I'm sorry? So I don't feel like it's a good use of our time to tell us how we got to this line. What's important to me is that we know how to properly interpret this line, okay? Yeah, if that's what's important. If we need to know what this line means, and if we don't know, oh, here I can extract. No? How do I? Can I make this larger? Here we go. Okay, so this is just based on the data points that I threw in. Okay, so I threw in 7 data points. Okay, and this is the equation that we've come up with. Huh? How did I get these numbers? I put it in Excel, and Excel produced this. What did I type into Excel? Okay, again, I'll make a separate video on how we can get this, okay? Just for now, suffice to say, in Excel you can get this, okay? You can get any other statistical software. You want to use Google Documents or Google Sheets, you can do that, and it will be able to produce this for you. And I can make a video on how to do this. You know, I have the latest version of Excel, so if you have an old version of Excel, the process is going to be different. I won't be able to make a video for that because I don't have that. I'm not going to go out and buy an older version of Excel just to make a video for you guys, okay? So if you have an older version of Excel, you're going to have to go on Google and say, how do I do linear regression with this version of Excel, okay?
So it's y equal 1.0.
Yeah, so my equation is y equals 1.0593x minus 3.7119, okay? So from Excel, I get y. And technically, there should be a hat, but there's not, okay? I get 1.0593x, 1.0593x plus, or I'm sorry, minus 3.7119. Okay, so here's a very important step, okay? Perhaps the most important step is which variable is x and which variable is y. So what does x represent and what does y represent? Now I have two variables. One is mother's height and one is daughter's height. Or, yeah, mother's height, and I said, quote, unquote, your height or daughter's height. Okay? Which one is the x and which one is the y? How do we know?
The value of the number is
Okay, so let's look at a data point here, right? Okay, so I have this first one, 64 for you and 66 for the mother. So does that point appear? So 64 is right here. So I got this data point's right here. So does that mean x is u or y is u? X is the u, right? X is u and y is the mother. Okay? So x will be your height or the daughter's height, and y will be the mother's height. Okay? Can we see that from our graph? That, just looking at any one of these data points, okay? Here we have 67, 66. We see that this data only lines up with your height versus the mother's height, okay? So x is your height and 66 would be the mother's height, okay? Yes, we have a question back there. Okay. And I'm sorry, those of you in the back, I know the text is probably small to read, and that's just, I don't know how to make it that much bigger. Okay? Okay, and so the line tells us what we would predict, and it's not always going to be exactly correct, okay? Okay, because these are just predictions. Okay, so if somebody is 64 inches tall, how tall do we predict? What does the line tell us is the prediction? Okay, so let's try this out. Okay, so here's someone is 64 inches tall. Okay, what is our prediction for the mother's height? Okay, so my x is equal to 64. Okay, and what I'm going to do is I'm going to plug 64 into x and use this to get a value for y. Okay, so you'll need your calculator. Okay, so I'm going to do 1.0593 times what? 64 minus 3.1179. Okay, and the result I get there will be my y hat, or my prediction for the mother's height. Okay, so I'm going to type in 1.0593 times 64 minus 3.1179. I hit enter and it spits out 64.6773. Okay.
How can I read this?
1.0593 x times minus 3.7. Oh, I'm sorry, 3.7119. I apologize. The 3.71.
Oh,
3.7119. Okay, so I had written it down. I had written it down incorrectly. I apologize. I thought something was a little off. 3.7119. So my apologies. So I typed that in wrong. Okay, so let me just type that in again. 1.0593 times 64 minus 3.7119. 64.0833. Okay? I get 64.0833. Okay?
How can I read this?
Y hat. You call it Y hat.
Y.
Yeah, so with the little cap, this is read as Y hat.
Y hat. Okay.
Y hat. Okay? All right, so let's just review what we've done. We used Excel to create a prediction line based on our data, right? We gave Excel 7 data points, and we said, based on these 7 data points, come up with a line of prediction. This is the line it came up with. And we're going to use this line to make a prediction for someone who is 64 inches tall. Based on this, we're going to say, what do we predict the mother's height to be? Okay, so we plugged 64 in for X, and it spits out 64.088833. Okay, does that make sense?
So Y equals this one is prediction, right?
Yeah, this is our prediction. Okay, so again, it's very important that we know which one is our X and which one is our Y, and we always use the X to make a prediction for Y, never the other way around. Okay, we plug in X to get a prediction for Y. Okay. Yeah, so I still haven't even finished that example. Okay, so we plug in X to predict Y. So in this case, and again, this is important, why I always ask for the interpretation, is we plug in the daughter's height, which is our X, right? Daughter's height, to predict the mother's height. Okay, so if a daughter is 64 inches tall, we predict that the mother is 64.0833 inches tall. Okay. So this is our prediction. Does it mean every woman who is 64 inches tall, her mother is 64.0833 inches tall? No. No. This is just a prediction, okay? All right. So the difference between, so later on maybe we go out and we find a woman who is 64 inches tall and we ask, how tall is your mother? Or we actually, maybe we have some data already. The difference between what the real data point is and our prediction is called a residual, okay? So there's something called a residual, and this is the difference between an actual data value and our prediction. And our prediction. Okay. So let's say, so that is the residual, okay? Okay, so looking at our data, let's say, so here somebody was 64 inches tall and her mother was 66 inches tall. So this is an actual data point. Actual data point. The daughter, 64, and the mother is 66 inches tall. Okay? Now, what did we establish? We said if a daughter is 64 inches tall, what is our prediction? Our prediction for the mother's height is what? Okay, so the mom's height is 64.0833. Okay, so what's the difference between the actual value? Yeah, so our residual will be equal to 66 minus 64.0833. So I'm going to do 66 minus 64.0833, and I get 1.9167. Can you say that's what's left over? So this is called a residual. It's the difference between the actual data and what we predicted. Okay, because what essentially we're doing is we're trying to create like kind of like a simple model or a simple rule for predictions. Okay, and we say, okay, well, if a woman's height is this, we predict the mom's height to be this. So we're just kind of trying to come up with a simple rule of prediction. Now, of course, it's not going to be 100% accurate, right? Because we can get 3 different women who are all the same height, but we ask, how tall is your mom? They're not going to give the 3 different women, assuming they come from different moms, their answers aren't going to be the same, right? We might have one woman who's 64 inches tall and her mom is 64 inches tall. We could have one woman who's 64 inches tall and her mom is 66 inches tall. We could have another woman who's 64 inches tall and her mom is, 60 inches tall or something. Okay, we can get all sorts of different answers. And so we say, yeah, I guess you could think of a residual as the amount that we cannot predict for. Okay, so our thing gets us in the ballpark, right? But it's not going to be 100% accurate. There's going to be something left over in terms of the difference between the actual and the data. Okay, so here we have a residual of 1.9167. Okay, and we say the actual height of the mother is 1.9167 inches taller than our prediction. No, it could be shorter. It could also, in this case, it was taller. It depends on the data, exactly. Okay, so huh? Yes, yes. Okay, so I mean, let's, what if? Here, I'll go back. Sure. Okay. If let's say the actual height of the mother, let's say we came across another daughter, and she is 64 inches tall, and her mother is 62 inches tall. What's the residual in this case? Okay, so let's say we come come across another daughter,
Okay.
and I'll put this up on the board in a moment, but you guys should be able to think of the answer right now, okay?
Okay.
Don't shout it out, but let's say we come across another daughter who is 64 inches tall, and we ask, how tall is your mom? And she says, my mom is 62 inches tall, 5'2". So she's 5'4". We ask, how tall is your mom? She says, my mom is 5'2", 62 inches tall. What's the residual in this case?
62 minus 64.
Okay, all right. So see if you can write a number on your piece of paper. Okay. So we're going to say, okay, another woman is 64 inches tall. Her mom is 62 inches tall. What is the residual in this case? Okay, so we should have gotten, with relative ease, negative 2.0833, right? Because we've already done the math from before, right? So we know if a woman is 64 inches tall, what is our prediction? We already did our math here. Okay, our prediction is 64.0833. Okay, so if the mother's height is 62, the residual is equal to 62 minus 64.0833, okay, and you get negative 2.0833. We should be able to do this in our heads, right? 62 minus this, okay? We don't need a calculator for this. We shouldn't, okay? And well, I mean, it's just like if somebody gave you $581.67 and they charged you $81, how much would you have left? $500.67, right? So some of this math we should be able to do, okay? Now, maybe we have an over dependence on our calculators and stuff. Okay, so anyway, we get negative 2.0833, and so if the mother's height is, so our actual value for the mother's height is what? 2.0833 inches shorter than our prediction. Okay, let's do one more example with do you guys all have this all written down? Okay. All right, so I'm going to put this line of, so again, from Excel, right? So let's just list this out. X will be the daughter's height. Y is the mother's height. And Excel, from Excel, we get we have y equal to 1.0593x minus 3.7119. Okay, so I'm going to say a woman is 67 inches tall. Her mother is 65.5 inches tall. Okay, what is the residual for this mother-daughter pair? Okay, so I'm going to give you guys a minute to figure this out, maybe a little bit of time. Okay, so this involves a couple steps. First, you've got to make a prediction for the mother, and then you got to find the residual. Okay, so take a few moments to figure that out. Okay, so your answer should have come out to be negative 1.7612. Okay, so step one is to figure out our prediction. What do we predict? So if someone is 67 inches tall, what is our prediction for the mother's height? Okay. What is our prediction for the mom's height? Yeah, so for this, all we do is we plug in 67 into our equation, right? So we get y hat is equal to 1.0593 times 67 minus 3.7119. This you just punch into your calculator. You just do 1.0593 times 67 minus 3.7119. Boom, 67.2612. Okay, so our prediction, 67.2612. Okay, so if we want to make a statement, we would say we predict the mother's height to be 67.2612 inches for women whose height is 67 inches. Okay, I want to make sure this statement makes sense to everybody. So any woman who's 67 inches, our prediction for their mother's height is going to be the same, 67.2612. Okay, but we know that that doesn't explain everything. Okay, and so in our case, the actual height is 65.5. So our residual is going to be 65.5 minus 67.2612, and I get negative 1.7612. Okay. So I do 65.5 minus this value, negative 1.7612. So the actual height,
So the residual you said equals 65.5?
65.5 minus our prediction, 67.216. So the residual is always the actual height minus our prediction for the points with that x value. Okay, so the actual height is 1.7612 inches lower than our prediction. Lower or shorter, it's It's when you're talking about height, to say shorter or lower, it's synonymous, okay? Inches lower than our prediction.
So this should subtract it, so the residual is the 65.5, is that plus 67 or minus 67?
Minus. So the residual is always a difference. Difference means subtraction, right? It's the difference between the actual and the prediction.
Can we tell our actual value for the mother's side is 1.7 inches shorter instead of inches lower?
Inches lower, inches shorter, it's saying the same thing, right? Okay. Or because it's negative, right?
Yes.
Okay. Is that okay?
In other words, the residual is equal to the value of x value.
Not the x, the actual. Okay. So remember, all the data numbers come in pairs, right? This daughter's height of 67 inches is paired with the mother's height of 65.5. Okay, so we take the actual height corresponding to 67, which is in this case 65.5. We take the actual height and we subtract off our prediction whenever we have that particular x value. Okay. So anytime, if another woman came in and she was 67 inches tall, what do we predict her mother's height to be? We still predict it to be 67.2612. Now, this other girl who's 67 inches tall, her mother could be 69 inches tall. Okay, in that case, would the residual be positive or negative? It would be positive because the actual height of the mother is taller than what we would have predicted. Okay? Yeah, so we have formulas and equations, but don't get hung up on these, okay? The concepts that the residual is the difference between the actual and the prediction. That's the important thing, okay? Yeah, you'll see something like this, okay? You guys, it is unfortunate that your learning has been reduced to whether something will be on the test or not. But what I want is I want you to be comfortable with looking at a scatter plot, because you're going to see these things, okay? You might not have to make them. You might have to make them, okay? But you'll see them, and you have to be able to understand them, okay? And it's unfortunate because, newspapers are shying away from printing scatter plots to display information because people don't know how to read them, or they make the wrong interpretations or wrong conclusions from them. But it is actually a very useful way to portray information. And so, we should be math literate and graph literate. We've got to be able to read graphs, okay? Nobody would say, I don't know how to read, okay? Or people would be embarrassed to say, I don't know how to read, okay? But somehow in our society it has become acceptable to say, I'm bad at math, okay? And we shouldn't, okay? We should, nobody has to be doing calculus, okay? It doesn't have to be that everybody has to be doing calculus, but we have to have some sense of numeric literacy, okay? We have to be able to look at scatter plots and interpret and say, oh, in this scatter plot, it's clear that the house with the most fireplaces has 7 fireplaces, okay? We've got to be able to look at scatter plots, make those types of interpretations. We've got to be able to, I don't expect or want you guys to know how to come up with 1.0593 on your own, okay? I learned it in school. It was great. No, it wasn't, okay? It was fine. I'm thankful that I know where it comes from, but in practice, I never come up with this number by hand. I always just throw it into the computer and it spits it out, okay? And even if I don't even expect you to have to put this into the computer and get this number out yourself, okay? But if you're given something like this, you've got to be able to make the proper interpretations from it, okay? That's what I want you guys to get out of here, okay? Being able to make the proper interpretations, being able to look at a graph and say, oh, you know what? As a woman's height increases, our prediction for what her mother's height would have been also increases, okay? Okay? Is that okay? Depending on the data. Now, based on our 7 data points, it seems our line of fit says if a girl is tall, we predict her mom to be tall. Okay? Now, of course, there's a lot of factors going into determining someone's height. Okay? There's generally a father involved, and that could also, if a tall person marries a short person, you might have tall kids, you might have short kids, you might have a mix. Okay? So there's a lot of things going into this. Okay? But if we had to come up with something like this. Okay? Why don't we take a short break? We'll come back at 3 o'clock. We'll get more into more details on this. Okay?